So welcome back. I think we had done in the last video the graphical representation over here, and now we will be seeing what is the base current and the input resistance at the base. So base current IB can be, this is again instantaneous value of the base current is equal to instantaneous value of the collector current divided by the beta value. This is the standard relationship between the collector current and the base current, whether it is instantaneous, whether it is DC, whether it is AC, does not matter. It's always, by divided by beta. Okay, IB and IC, collector current and base current, whether DC or AC or instantaneous, will always be having a relationship like this. Okay, by beta. So, and this IC is we have already written that we already calculated it to be, the value which is, this. We have written this. Same thing is being reproduced there, right? And that value turns out to be this quantity over here. So we are just expanding it and trying to write that IC by beta plus 1 by beta IC VT by VB. And this value is, because it is instantaneous, it is equal to the DC plus the input signal or AC signal, DC plus the signal component. That's what we have written here. DC bias value IB and the signal component IB of the instantaneous value IB. So therefore, this value IB, this term and this term both are same. IC by beta is equal to IB. Therefore, this quantity should be equal to this. So that's why we have written here IB is equal to 1 by beta, IC by VT, VB. And we know that this is equal to GM. That's why it is written as GM by beta into VBE. GM by beta into VBE. So we have a relationship here between the base current and the base voltage, base to emitter voltage rather. So the input resistance at the base is generally considered as the input voltage at the base divided by the base current, VBE by IB. So if I take this on this side, VBE by IB, and this term if I take on that side, it will become beta by GM. So therefore, VBE by IB, which is generally written as R pi, and sometimes it is also written as RB dash E. Okay, it's also written as RB dash E also in the literature, or you can always write it as R pi. R pi is nothing but the value which is, VB by IB, and that is beta by GM. Okay, beta by GM. And GM itself is IC by VT. And, this VT will go to the numerator. IC by beta you can take to the denominator of the denominator. Then it will become VT by IB. But standard formula to remember is this only. R pi is beta by GM. R pi is beta by GM. You need not remember this. Okay. You need not remember this. Sometimes people will write, beta, so to say, VT by IC also, beta VT by IC also, people write, but standard is beta by GM. Sometimes we in the numericals might have used beta VT by IC because denominator of the denominator will go to the numerator, right? So R pi is now, directly dependent upon beta and inversely proportional to the IC, okay? Directly dependent upon beta and inversely proportional to the IC. VT is considered the constant value. Volt thermal equivalent is just, as I said, 25 millivolts, okay? So this is the relationship of the input resistance looking at the, so to say, base, okay, between base and emitter, but generally we'll say at the base, at the base. Similarly, at the emitter also we can find the input resistance. At that time we'll call that as RE. We'll call that as RE, right? We'll call that as RE. And emitter current is what we are writing here. IE will be equal to IC by alpha. Like IB is equal to IC by beta, we have IE is equal to IC by alpha. The value of alpha is, almost equal to 1, but beta is, we have taken 50 to 150 value. Okay. So this is almost equal to 1, but still we write it over here. IC by alpha is equal to IC by alpha. This is the DC current, and this is the AC value of the current or signal component. Whereas this is instantaneous. All these, this and this both are instantaneous. This is DC and this is the signal component. And this is nothing but the DC value of the emitter, which we have written over here. And this is the AC of the signal value of the emitter, which we have written here. IE is equal to IC by alpha. And again, the IC we have found out again in the earlier, what you call slide. There we have written IC by VT into VBE. And IC by alpha is again the value of IE. I by I into VBE by VT. And that always can be written as, the value of GM also can be written. We have already written that it is GM by VT by IC is the IC by VT is the value which is GM. This is nothing but GM, and hence we can write GM VB by alpha. So now the input resistance looking at the emitter will be VBE by IE, VBE by IE, and that will become alpha by GM. Okay, alpha by GM. So alpha by GM for the input resistance at the emitter, beta by GM for the input resistance at the base. That's the standard thing. Alpha by GM, beta by GM. You can see that here. This is beta by GM, and here it is alpha by GM. Alpha is almost equal to 0, alpha almost equal to 1. So sometimes this is written like this, but the accurate value is alpha by GM only. Okay, alpha by GM only. And the relationship between both of them will be, one is beta by GM, another is alpha by GM. Then definitely we will have, so to say, the relationship between this as, both of them we can try to write. One is the alpha by GM and another is beta by GM. So VB is equal to IP R pi and I is equal to IE RE. So it will be just IE by IB into RE. R pi will be equal to IE by IB into RE. And we know the relationship between the emitter current and the base current, and that is nothing but beta plus 1. Beta plus 1. Okay, into RE. Beta plus 1 into RE. So I'll stop at this for today.